In this video, we'll be looking at how to solve systems of equations in three variables. So let's go ahead and get started. So let me give you some steps. There's going to be three. The first one is to use elimination to obtain two equations in the same two variables. So this is what we were doing previously. We were solving two equations in x and y. And so we know how to do that now. So that's what we need to do first, is come up with an equation or system of two equations in the same two variables. And then step two, we need to solve the system in step one. So in step one, we have a system of two equations in two variables. In step two, we're solving it. And then finally in step three, we're going to find the third variable using one of the original equations. So when we solve the system that we came up with, we'll get two of the variables, and we get the third by using one of the original equations. All right, so let's go ahead and get started. So if you look at this system here, we have three equations and three variables, x, y, and z. And I'm looking at the x terms, and I could eliminate x by multiplying the first equation by -3 and adding it to the second equation. Similarly, I could multiply by -2 in the first equation and add that to the third equation and eliminate x. So that's one option. But if you look at the y's, notice there's a 2y in equation 1 and a -2y in equation 2. Now I don't see that with the z's. And so for me, I would choose to eliminate y. So what my point here is, we could eliminate x, y, or z. We're looking for the easiest option here. So I'm going to go ahead and make this comment. I choose to eliminate y because it looks the easiest to eliminate. So let's go ahead and work with that, or let's eliminate y. So what I'm going to do is, first of all, I'm going to use equations 1 and 3. So let me label my equations. And I'm going to use equation 1 and 3, and I'm just going to add those together. And by the way, this is step 1. So that's equation 1, and there's equation 3. And so we can add these together. 1x and 2x is 3x. Notice the y is eliminated. We're going to get 8z. And that's equal to 19. So 3x plus 8z equals 19. We're going to call that equation 4. And let's go ahead now and so here's the thing. We used equations 1 and 3. And so one of the important things as we go through this process is you have to use all three equations. So I'm going to go ahead and put that up here at the top. In doing step 1, you must use all three equations. So as we look to come up with two equations in the same two variables, we're going to need to use all three. So we already used 1 and 3. So now I'm looking at, I need to use 2, and you can see that we have a 1y, whoops, let me change to pencil here. So what I'd kind of like here is to have a 2y there, or actually maybe a -2y there. And so I could multiply that second equation by -2 and add it to the first equation. So let's go ahead and use equations 1 and 2. So we're going to have equation 1 and -2 times equation 2. So I'm going to go ahead and show you one way you can do this, because I know sometimes students will make mistakes. Notice I'm going to write a little -2 by each of the terms. Basically all we're doing is multiplying both sides of the equation by -2. And when we do that on the left, we have to distribute. So all three of those terms get multiplied by -2. And so we're going to get -6x. -2 times y is -2y. -2 times -2z is 4z, and -2 times 2 is going to be -4. And so now we're ready to add the two equations together. A 1x and a -6x gives you -5x. Y is eliminated. We get 7z And then on the other side, we get 9. So negative 5x plus 7z is equal to 9. And we're going to go ahead and call this equation 4. All right, so we're done with step 1. We just found two equations in the same two variables, x and z. Notice as we did that, we had to eliminate we had to eliminate y twice, and we used all three equations. All right, so let's move on to step 2. Let's solve this system of equations in two variables. So basically I'm using equation 4 and 5. Now I'm looking at this and I don't see a nice easy way to, I can't just multiply one of the equations by something and add the two together. So I think I'm going to go ahead and focus on my x values here, and I'm going to want to get a 15x and a minus 15x when I add these equations together so I can eliminate x. And so let's go ahead and multiply equation 4 by 5. That'll give us 15x. And so let's do that first. So we're going to get 5 times 3x. That's actually, I did want to write the other. We're also going to do 3 times equation 5. So notice negative 5x times 3, we'll get negative 15x as the first term for the second equation. So we're going to end up with opposites for x, which is what we want. So now let's go ahead and do this. So 5 times 3x is 15x. 5 times 8z is going to give us 40z. And 5 times 19 is 95. In the second equation, let's see, we have 3 times negative 5x, that's negative 15x. 3 times 7z is 21z. And 3 times 9 is 27. So let's go ahead and add these equations together. X is eliminated. We're going to get 61z. And when you add 95 and 27, you get 122. So 61z is equal to 122. And in fact, a z would be 2 there. You can divide both sides by 61. Now you got to be careful as you're doing this. You got to keep track of things. We just, keep in mind we're trying to solve this system here. And so we just found z. We want to go back and find x next. And so I'm going to go ahead and use equation 4. And I'm going to, plug in 2 for z. So we have 3x plus 8 times 2 is equal to 19. And so that's 3x plus 16 equals 19. And I'll subtract 16 on both sides, and you get 3x is equal to 3, which means x is 1. So remember, when we were solving systems of equations in two variables, usually we would get a point as a solution with an x and a y value. Now here we're going to have 3 values, an x, a y, and a z value. And so I'm going to go ahead and write what's called an ordered triple. And we know x and we know z, so we have everything except for y. And again, this is called an ordered triple. All right, so let's go ahead and we're now on step 3. We're going to go back, and why don't we go ahead and use the first equation? I think I like that one the best. And so I'm going to write that down, and I'm going to put in 1 for x and 2 for z, and then I need to solve for y. So I have 1 plus 2y, 1 plus 3 times 2 is 6. We're going to get 7 plus 2y equals 13. We'll subtract 7 on both sides. We get 2y equals 6, which means y is equal to 3. All right, so that is our solution. Now I also want to add the other two ways that we describe our system. Remember, we had said that if a system has at least one solution, it's called consistent. And so our system here is consistent. And then the other thing we talked about was being dependent or independent. The dependent case was where it turned out graphically that we had two equations that were equivalent. If you graph them, you get the same line. And you end up with, anyway, that's the case that we call the dependent case. That's the case where we said there was infinitely many solutions. That's not what we have here. This is our most common case where we have a single point of intersection. This is not a dependent system, it's independent. All right, let's move on to the next problem. All right, so in number 2 here, go ahead and look at this one and think about which variable you would like to eliminate. Now, honestly, I would normally eliminate z here because you can see we have a 3z in equation 1 and a minus 3z in equation 3. And so that would probably be the easiest way to do this one. But I want to show you, I want to look at the first column here, and I want to eliminate x because we don't always get this case where we get opposites. And so I want to show you how we would eliminate x in this problem, even though I would normally choose z because it would be a little bit easier. I just want you to see an example like this one. And so we're going to eliminate x. Notice if we combine, let's go ahead and make a comment here. I'm choosing to eliminate x. Again, we could do x, y, or z. We make a choice. We're looking for the easiest way. And sometimes, like if this had been like a 5, look at all these coefficients. There's really nothing easy about eliminating y if you're working with those 3 coefficients. So sometimes there's obvious, here I would not want to eliminate y in that situation. Excuse me. But a lot of times what we get is if we can find a 1x or a 1y or 1z, we can use that to eliminate the x when we work with the other 2 equations. So let's go ahead and eliminate x. So I'm going to label our 3 equations, and you can see equation 1, I need to multiply by -3 so that I'll have a -3x. And so that's what I'm going to do here as I do step 1. I'm going to multiply -3 times equation 1. So let's go ahead and do that. -3 times x. And again, I'll go ahead and write out the -3's there that I'm multiplying by. We get a -3x and a plus 6y, and a minus 9z is equal to -15. And then I'm just going to rewrite equation 2. And so now let's add these together. The x is eliminated. 6y minus 3y is 3y. And then we're going to get a minus 8z and -15, and 9 is -6. And we'll call this equation 4. So we used equations 1 and 2 to eliminate x. And so now we need to do that again, but we've got to include equation 3. We haven't used equation 3 yet. And so it makes sense to use 1 and 3, so I can use that x in equation 1 to get a minus 5x, and I can add 1 and 3 together. So that's the idea here. So -5 times equation 1. Now I'm going to go ahead and erase what I did earlier here. Now, depending on your arithmetic skills, you could just do this in your head, but this time I am going to write it out. So we're multiplying each of these by -5. All right, so let's see, we have -5 times x, that's minus 5x. A -5 times a minus 2y is a plus 10y. -5 times 3z is a minus 15z. And -5 times 5 is -25. And let me go ahead and write equation 3. And let's add these together. You can see again our x is eliminated. That's what we planned to do. We're eliminating x in both cases. And so we're going to get 11y, and then minus 18z is equal to -22, and we'll call that equation 5. And let me go ahead and move it and put it right underneath equation 4. And so now we're into the second step. We came up with two equations in y and z, and now we're going to solve that system. Excuse me. All right, so, let's see. There's no nice way to multiply just one of these equations by something. I think I'm going to look here at these y terms, and I'm going to want to make one of them a 33y and the other one a minus 33y. So I'm going to go ahead and multiply the first, or equation 4, by 11. Excuse me. So I'll get 11 times 3y is 33y, 11 times a negative 8z is negative 88z, and 11 times negative 6 is negative 66. And then I'm going to need to multiply the second equation by negative 3, equation 5. Negative 3 times 11y, that's negative 33y. Notice we got what we were looking for. We're trying to eliminate y here, and we do have opposites. Then we'll do negative 3 times a negative 18z, that's 54z. And negative 3 times negative 22, that's positive 66. So let's go ahead and add our equations together. Y is eliminated. A negative 88 and 54, that's going to be negative 34z is equal to 0. Well, you can divide both sides by negative 34, but z is going to have to be 0 here. Excuse me. So now I need to use one of either equation 4 or 5 to find y. So I'm going to go ahead and use equation 4. 3y minus 8z is equal to negative 6. And let's plug in 0 for z. We get 3y is equal to negative 6, which means y is negative 2. All right, so notice we found z and y, so I'm going to write an ordered triple where the y value and the z value is 0. All right, so let's see. I need to find x, so we could use any of the first three equations. Why don't we use equation 1? Notice we're in step 3 now. So we have x minus 2y plus 3z is equal to 5. And we're going to plug in negative 2 for y and 0 for z. So we'll get x plus 4 plus 0, or just x plus 4, is equal to 5, which means x is 1. So our solution here is the point 1, negative 2, 0, or the ordered triple. Again, this is a consistent system because we have at least one solution, and the system is also independent. Now I want to point one last thing out here. Well, first of all, a couple of things. There's a lot of algebra here that we're doing, and these are long. I think the most important thing is understanding the process, but keep in mind if you're one of those people that tend to make a lot of mistakes as you're adding integers or multiplying or whatever it is, if you make one mistake along the way, it's going to throw everything off. So I think that's the hardest part here. It's really important to understand the process, but these are the kinds of problems you want to do when you're alert and awake, because if you make a mistake, it's going to mess everything up. You will not get a right answer, at least not the right way anyway. Okay, the other thing I wanted to point out here is these are very easy to check. So if you're taking a test, you can know if you did it right or wrong. We're just going to plug the numbers in. So let's go ahead and do that. So I'm going to go ahead and plug in 1 for x, negative 2 for y, and 0 for z into the first equation. So we have 1 minus 2 times negative 2 plus 3 times 0 equals 5. Now you can use your calculator, you can just do that in your head. That's 1 plus 4 equals 5, which is true. And then we have 3 times 1 minus 3 times negative 2 plus 0 equals 9. That's plugging the point into the second equation. And so we'll have 3 plus 6 equals 9, and that is true. And then finally, for the last equation, it will be 5 times 1 plus negative 2 minus 3 times 0 equals 3. Notice that would be 5 and a negative 2 equals 3. That is true. So you can use your calculator or you can just use your own arithmetic skills to check these and verify that your answer is correct. All right, that's it for this video. I'm going to do a second video where we're going to do 2 more problems, one that's a little bit different and one that's one of our special cases.